warahmatullahi wabarakatuh. We are from Group 1. Today we are going to present our discussion about derivatives. Before we start, let us introduce ourselves. My name is Tyassatrio Kuncorowibowo, student number 1736.
I'm Fabian Elsony, NRB 48.
My name is Maulana Ahmad Razaq Payapo, NRB 62.
My name is Taufik Reza Nurdiansyah, NRP 79.
My name is Firman Erawan Hakam, NRP 059.
My name is Zuhal Amirul Haq, NRP 10.
My name is Sinta Bella, NRP 24.
Okay, let us start our present.
First, my name is Taufik Reza Nurdiansyah. I'm going to explain about the history of derivative. Calculus is the most important material to study in mathematics. In calculus, there are integral and differential. Recently, this concept is being developed as a calculus differential. The first modern calculus was found in Japan in 17th century based on Sekikowa thoughts. In Europe, John Wallis and Isaac Barrow contributed a lot in modern calculus. Modern calculus that is more constructed are from the development of basic calculus concept by Newton and Leibniz. Therefore, both of them are recognized as the pioneer of the calculus because they've managed to combine previous concepts. This has a very significant change in the development of mathematics and physics.
I'll explain about the definition of derivatives. So what derivative is the rate of change of a function with respect to a variable. Derivatives are fundamental to the solution of problems in calculus and differential equations. In general, scientists observe changing systems or dynamical systems to obtain the rate of change of some variable of interest, incorporate the information into some differential equation, and use integration techniques to obtain a function that can be used to predict the behavior of the original system under diverse conditions.
Hello, good evening. I'm Fabian, and now I will explain about the function of derivative. There are some functions of derivative. The first is finding acceleration. It is useful to have a plane land safely on the airport, so its acceleration will not pass the limit. As you know that the acceleration is the first derivative of velocity. And the second is limit cases. Derivative method is the easiest way to solve the limit problem. When you find it is difficult to solve the limit problem, you can choose the derivative method. The third is economic side. Derivative can also use to calculate the profit, the optimization, or the minimum fees to have a maximum productivity. And the last is finding max and minimal values and also the shape of the graph. If the first derivative of fx is bigger than 0 and for every x in that interval, so the fx is increasing on that interval. And if the first derivative of fx is less than 0, then for some x in that interval, so the fx is decreasing in that interval. And also when the first derivative of fx is equal to 0, then the x in that interval is constant.
This is the formula of derivatives. String towards 0 within written as limit. So f and x equals limit delta x to 0 and times by fx plus delta x minus fx divided by delta x. So the derivative of f equals the limit as delta x goes to 0 of f delta x plus x minus fx over delta x. So the formula of derivative can also be written as dy per dx equals fx plus dx minus fx divided by dx. So the process of finding a derivative is called as differentiation.
My name is Sinta Bella. I will explain the specific characteristic of derivative. 1. Constant law. If fx equals a with k is a constant and x is any constant, then the first derivative of fx equals 0. 2. Identity function law. If fx equals x, then the first derivative of x equals 1. 3. Power law. If fx equals x to the power of n, with n is a positive number, then the first derivative of fx equals n x to the power of n minus 1. 4. Constant multiplier law. If k is a constant and f is a derived function, then kfx accent equals kf accent x.
And then is addition law. If we have fx and gx, then fx plus gx have a derivative f accent x plus g accent x. And subtraction law. If fx minus gx, the derivative is f accent x minus g accent x. And then multiplication law. If we have the function fx and fx times gx, the derivation is f accent x times gx plus fx times g accent x. And then division law. If we have fx per gx, the derivative is f accent x times gx minus fx times g accent x per gx to the power of 2.
Hello everybody, my name is Firman, and now we solve the three problems in my slides. Now, in the number 1, I will question fx equal 6 power x 3 minus 9x plus 4. In the 6, minus. Nah, in this answer is number 1. Dah. In the number 2, I will explain is y. Y is 2 or 3 4 minus 1 10 t sorry t minus 1 plus 13 x t 3 minus 20 t 13. And this answer number 2. The number 3, G, Z, 4, 7, Z, 7 minus 1, minus 3, minus 7, Z, minus 7, minus 1, then 9, 20, H, Z, and 6, plus 21, Z, minus h plus 9. And this the answer number 3.
Assalamualaikum warahmatullahi wabarakatuh. My name is Maulana Ahmad Razaq Payapo. In here, I will explain about application of derivative in marine engineering. This I will show the problem in marine engineering. Number 1, a ship moves in a straight line so that after x second it fulfills the equation fx equal 6x the power of 3 plus x to the power of 2, with fx is state in matter. What is the velocity of the ship at x equal to second? The clue is finding the velocity of the ship from the equation. And this is the solution of number 1. Fx equal 6x power of 3 plus x the power of 2. And then f accent x equal 18 x power of 2 plus 2x. And then we input 2 second or number 2 in this f accent 2 equal 18 times by 4 plus 2 times by 2 equal 76. So the velocity of x equal to second is 76 meter per second. And then now I will explain in different problem in number 2. A cannon on a warship is being fired vertically with an ignition speed at 10 meter per second. When the cannon ball reaches t second, fulfilling the equation ht equal 30t minus 6t power of 2, with ht is the height of the cannonball that is measured in meter. When will the cannonball stop? And this is the solution for number 2. From the question, we know ignition velocity or V0 is 10 meter per second. The position of cannon ball at t second equal ht equal 30t minus 6t power of 2. Question: when will the cannonball stop and hit the target velocity? Is the derivative of position with time, so Vt equal h accent t, or Vt is the derivative of ht equal 30 minus 12t. The cannonball will stop when the velocity is 0. So Vt equal 0. We input 0 to this. V0 equal 30 minus 12t equal 0. The t value is 2.5. So the cannonball will stop at 2.5 seconds after ignition. And now I will explain in different problem again. In number 3, a company produce X ships. Every product give a profit with 225x minus x power of 2 in Indonesian rupiah. To make sure that the company could reach the maximum profit, how many ships that have to be produced? This is the solution for number 3. The equation is hx equal 225x minus x power of 2 for one ship. So for x ships, we put x to this. We use k. X equal 225x power of 2 minus x power of 3. To reach the maximum profit, then k accent x equal 0. 450x minus 3x times to the power of 2 equals 0. X times 450 minus 3x equals 0. And then we have two value of x is 0 and 150. So to make sure that the company can reach its maximum profit, the company must produce 150 ships. That's for me. Thank you.